So let's look at the most important part in data analysis is two things, right? So I can think of data points as vectors. That's the first thing because I took features and so on, right? The second most important thing is I want to look at the similarity of two vectors, right? So how do you find the similarity of two vectors? What is the notion? Suppose I have a vector like this. How do you find whether they are similar or not? Huh? Okay, what is cosine similarity? Is it just dot product? Huh. So essentially, I should quantify the angle, right? So if they are aligned, I should get very high value. If they are orthogonal, so-called orthogonal, I should get 0, right? That's what similarity is, right? So I should n dimension. 2 dimension, it's easy, right? I can define cos theta, right? It's very easy. But for n dimension, what is cos theta? I mean, there is what do you mean by theta, right? You have an angle theta there. Uh, I can know, right? So it's like weird. Even in 3 dimension, what do you mean by angle? Weird. So now, yeah. See, think about it. There are so many angles that I can define, right? So yeah. So there is no one angle, right? And therefore, there is no one similarity. You should look at three different similarities. So one natural way of so there should be a way by which we can define similarity of two matrices, two vectors, right? So towards that we need a definition for similarity that's called or I'll say similarity. So this is through what is known as inner products, right? And we also need closeness, right? Well, there is a difference between close and similarities, okay? So how do you define close? Two vectors are close. It depends on the distance, right? You have to measure the distance between two vectors, or in general, it's called norms. Okay, so we will see what these things are in the next class onwards. Okay, so we'll try to figure out more properties. Just to for those who are curious, how many of you know what an inner product is? Okay, fine, good. How many of you know what norms are? I think you would have studied norms in your calculus and other courses, right? Even in linear algebra. Now, I'll give you how many of you know what is an expected value? Probability. Naveen would have taught you, right? What is the expected value of some x? You know what is an expected value of x? Mean value, right? So now I'll define a new inner product, okay? Inner product is like dot product, okay? Okay. Why is this an inner product? It satisfies all the properties of a dot product, right? Dot product is what? A transpose B. It's linear in A, linear in B. It doesn't matter whether you commute, right? A transpose B same as B transpose A, right? And we have all the other properties, right? A transpose A is always positive, non-negative. It's equal to 0 only if and only if A is 0. Similarly here, x comma x is always non-negative provided x is 0, right? So there are similar properties. So now the moment you have the notion of angle, I know how to, or notion of inner product, I know how I can bring in the notion of distance. So what is distance between two vectors? Okay, what is the length of a vector? Easy, right? This is how we define, right? X inner product as root of that. So what will be the length or norm of this thing? Root of x squared, right? How do you define the angle between two vectors? So you take transpose y divided by norm of x, norm of y, right? This is how, because you scale x to make it a unit vector, scale y to make a unit vector, look at the inner product, right? So what is the analog of this for random variables? Surprisingly, you get, sorry, expected value of xy divided by, this is the similarity, right? What is this called? I'll end here. What is this called in probability? Studied something like this? It's called correlation coefficient, right? So that measures the similarity, right? So it comes from somewhere. Anyway, so I won't go into the details of this, but this is just to for the sake of curiosity. Okay, so I'll end here. Okay, thank you.